Let us know about frustum of a cone. Consider a scenario. We will take a right circular cone and remove a portion of it. There are so many ways to remove. But one particular case that we are interested in is the removal of a smaller right circular cone by cutting the cone by a plane parallel to its base. If a cone is cut by a plane parallel to its base, the portion of a solid between this plane and the base is known as frustum of cone. To achieve that, let us do the following activity. Take some clay, or any other such material, and make a cone. Cut it with a knife parallel to its base. Remove the smaller cone, that is, the shape similar to a funnel. The portion that we are left with a solid is called a frustum of the cone. The frustum of the cone has two circular ends, with different radii. Frustum is a Latin word, meaning piece cut off. Flower pots have a shape, as the frustum of a cone. Let us see some formulae related to frustum of the cone. Volume of the frustum of the cone equals 1 by 3 into pi into h into r1 square plus r2 square plus r1 into r2. The curved surface area of the frustum of the cone equals pi into r1 plus r2 into L, where L equals slant height of frustum, that is square root of h2 plus r1 minus r2 whole square. Here, r1, r2 are two radii of bases. H is the vertical height of the frustum. Total surface area of the frustum of the cone equals pi into L into r1 plus r2 plus pi into r1 square plus pi r2 square, where H equals vertical height of the frustum, L equals slant height of the frustum. R1 and R2 are radii of the two bases, or ends, of the frustum. Let us see examples on frustum of cone. Example 1. The radii of the ends of a frustum of a cone 45 cm high are 28 cm and 7 cm. See figure. Find its volume, the curved surface area, and the total surface area. Take pi equals 22 by 7. Solution. Given that the radii of the ends of a frustum of a cone R1 equals 28 cm, and R2 equals 7 cm. Height of the cone H equals 45 cm. We need to find its volume, curved surface area, and total surface area. We know that volume of any frustum is calculated using the formula 1 by 3 into pi into h into r1 square plus r2 square plus r1 into r2. On substituting the values of pi equals 22 by 7, h equals 45 cm, r1 equals 28 cm, r2 equals 7 cm, we get 1 by 3 into 22 by 7 into 45 into 28 square plus 7 square plus 28 into 7. On simplification, we get volume of frustum of a cone equals 48,510 cm cube. Now we need to find the curved surface area of the frustum of a cone, for which, first we need the value of slant height L. As we know that the slant height L of the cone can be calculated using the formula square root of h square plus r1 minus r2 whole square. On substituting, the h equals 45 cm, r1 equals 28 cm, r2 equals 7 cm, we get square root of 45 square plus 28 minus 7 whole square. This is equal to 3 into square root of 15 square plus 7 square. This implies that slant height L equals 49.65 centimeters. We know that the curved surface area of the frustum can be calculated using the formula pi into r1 plus r2 into L. On substituting, the r1 equals 28 centimeters, r2 equals 7 centimeters, and L equals 49.65 centimeters, we get 22 by 7 into 28 plus 7 into 49.65. This is equal to 5,461.5 centimeters square. Therefore, the curved surface area of the frustum equals 5,461.5 centimeters square. Now, let us calculate the total surface area of the frustum. the total surface area of the frustum is calculated using the formula pi into L into R1 plus R2 plus pi into R1 square plus pi into R2 square. On substituting, the pi equals 22 by 7, R1 equals 28 centimeters, R2 equals 7 centimeters, and L equals 49.65 centimeters, we get 5461.5 plus 22 by 7 into 28 square plus 22 by 7 into 7 square. This is equal to 8079.5 centimeters square. Therefore, the total surface area of the frustum equals 8079.5 centimeters square. Example 2. Hanumapur and his wife Gangamma are busy making jaggery out of sugarcane juice. They have processed the sugarcane juice to make the molasses, which is poured into molds in the shape of a frustum of cone, having the diameters of its two circular faces as 30 centimeters and 35 centimeters, and the vertical height of the mold is 14 centimeters. See figure. If each centimeters cube of molasses has mass about 1.2 grams, find the mass of the molasses that can be poured into each mold. Solution. Given that 1 of the diameter of frustum equals 35 centimeters, other diameter of frustum equals 30 centimeters, and the vertical height of the mold equals 14 centimeters. 1 centimeters cube volume equals 1.2 grams mass. We need to find the mass of the molasses that can be poured into each mold. Since the mold is in the shape of a frustum of a cone, the quantity, or volume, of molasses that can be poured into it equals pi by 3 into h into R1 square plus R2 square plus R1 into R2, where R1 is the radius of the larger base and R2 is the radius of the smaller base. This implies that R1 equals 35 by 2 and R2 equals 30 by 2, since radius equals diameter by 2. On substituting the values of pi equals 22 by 7, h equals 14 centimeters, R1 equals 35 by 2, R2 equals 30 by 2, in volume of frustum of cone formula, that is, pi by 3 into h into R1 square plus R2 square plus R1 into R2. We get volume of frustum of cone equals 1 by 3 into 22 by 7 into 14 into 35 by 2 square plus 30 by 2 square plus 35 by 2 into 30 by 2. On simplification, we get volume of frustum of cone equals 11,641.7 centimeters cube. It is given that 1 centimeters cube of molasses has mass 1.2 grams. Therefore, the mass of the molasses that can be poured into each mold equals 11,641.7 into 1.2. This is equal to 13,970.04.